Before we proceed with the statement, it is far more persuasive to sort out what the big thing is: molecular gasoline pedals. The Large Hadron Collider, LHC, which CERN runs, consists of superconducting magnets in a 17-meter wide ring. In addition, it is the most well-known particle accelerator in the world and represents humanity's highest scientific accomplishment. In fact, it is so powerful that it can reproduce the precise conditions of the early universe. However, the system could hold the key to unlocking the universe's greatest mysteries. The secret to something truly unique started in 1954. CERN is regarded as one of the most notable research establishments, with 23 member states and numerous researchers working together. The LHC is the centerpiece of CERN's innovation, but it is just one component of a much larger network of particle accelerators and experiments. Unlike traditional transportation routes for people or automobiles, these accelerators propel subatomic particles at nearly the speed of light. During its operation, the LHC accelerates protons to near-light speeds, sending them into high-energy collisions that mimic the universe's conditions immediately after the Big Bang. These impacts generate temperatures far higher than those found in the Sun's core. Powerful magnets facilitate the proton's journey, while intricate cooling systems maintain temperatures below absolute zero. The LHC's beams are designed to collide at 4 specific locations along the accelerator ring, where massive detectors, ATLAS, CMS, ALICE, and LHCb, analyze the resulting particle interactions. Each detector has a unique role, investigating different aspects of particle physics. Scientists sift through the debris from these collisions, searching for evidence of elusive phenomena such as the Higgs boson, often called the God particle, and other fundamental building blocks of the universe. By focusing on the microscopic world, we gain insights into the cosmos. Yet, with every answer comes a new question, and each discovery presents a new challenge. The LHC is more than just a scientific instrument. It embodies human curiosity, technological advancement, and our drive to understand the fundamental forces shaping the universe. However, as we push the boundaries of knowledge, we must also consider deeper ethical and existential questions, including the risks of delving into the unknown. The power of particle accelerators has already demonstrated its potential dangers. In 1978, Anatoly Bugorsky, a Russian physicist, experienced a catastrophic accident at the U-70 synchrotron in Russia. Due to a failure in safety protocols, his head inadvertently crossed into the path of a high-energy proton beam. The beam entered the back of his head and exited through his nose. Bugorsky described seeing a flash brighter than 1,000 suns, yet he remained conscious and even walked to a medical facility for treatment. The beam left a trail of destruction, burning through bone and tissue, causing partial hearing loss and facial paralysis. Miraculously, his cognitive abilities remained intact, and he continued his scientific career. His experience serves as a reminder of the immense power, and the potential dangers, of particle accelerators. The LHC and other particle smashers must not be underestimated. Concerns raised by leading scientists suggest that high-energy experiments could have unintended consequences. One of the most unsettling possibilities is the formation of a miniature black hole. In theory, such a phenomenon would be short-lived, as any black hole created would evaporate almost instantly due to Hawking radiation. However, the mere possibility has sparked debate, anxiety, and awe at the power we wield. To understand this concern, it's essential to grasp how particle accelerators work. When protons collide at nearly the speed of light, the energy involved is so immense that it alters spacetime itself. This is analogous to dropping a heavy object onto a tightly stretched trampoline. If the object is massive enough, it could create a deep well that pulls everything nearby into it. Some physicists speculate that hidden dimensions within our reality could amplify these effects. If extra dimensions exist, the LHC could, in theory, create a gravitational well strong enough to generate a microscopic black hole. This idea intrigued the late Stephen Hawking, who theorized in his writings that under extreme energy conditions, the Higgs boson might become unstable. This could trigger a catastrophic event known as vacuum decay, in which a ripple in spacetime could theoretically consume the universe. Sir Martin Rees, a distinguished English astronomer and cosmologist, also expressed concerns about the risks of high-energy particle collisions. In his book on humanity's future, he explored the potential dangers associated with particle smashers, including those at CERN. While he considered such catastrophic outcomes to be unlikely, he argued that even the smallest probability of disaster should be taken seriously given the immense stakes involved. CERN researchers have conducted extensive safety studies to evaluate these risks. Physicist Brian Cox, a former researcher at CERN, has emphasized the rigorous safety measures in place. He reassured the public that the energies involved in the LHC's experiments are within the natural limits experienced by Earth through cosmic radiation. Even if a microscopic black hole were to form, scientists predict it would be so minuscule and unstable that it would decay almost instantly, posing no real threat. However, some theorists have taken these ideas further, speculating that LHC experiments could open a portal to another universe or dimension. While mainstream science dismisses this as highly improbable, the concept has captivated the imagination of many. Some fear that these experiments could inadvertently unleash forces beyond our understanding. Sensationalized media coverage has even fueled speculation about opening a gateway to hell. Despite these fears, the LHC remains one of humanity's greatest scientific endeavors. It continues to push the boundaries of our knowledge, revealing the hidden structures of the universe. While caution and ethical considerations are necessary, the pursuit of understanding remains at the heart of scientific exploration. The embers of doubt, but how did this concept come about? What does it mean in terms of research and science? The idea of extra dimensions isn't new. String theory, a major theory in physics and a candidate for a single theory of everything, points to the possibility of significantly more than the usual 3 dimensions of space. Time is another dimension, and additional dimensions may exist but remain hidden from our perception. It is possible that they are compressed or concealed, yet they could theoretically be accessed or disclosed. Now, imagine a situation where the Large Hadron Collider, LHC, functions as a massive key, opening doors that have been locked since the beginning of recorded history. Protons collide at energy levels never before produced on Earth. In theory, these collisions could create ripples or waves that provide glimpses into these hidden dimensions. If any such dimensions exist, the LHC may indeed be capable of discovering them. However, before we become overly exuberant, we must temper speculation with caution. Despite the LHC's undeniable power, there is no conclusive evidence that it will open another door to the universe, let alone to hell itself. Yet, the allure of the unknown, combined with the almost mystical nature of quantum physics, ensures that these ideas will continue to captivate the public imagination. Should we be worried about the risks associated with the LHC? It's easy to get carried away by sensational headlines and fears of global catastrophe. However, the truth is that researchers at CERN are fully aware of any potential dangers. They have taken every possible precaution to ensure the safety of these experiments and continue to monitor and test their work with the highest degree of diligence. The advantages of this research are extraordinary. Advancements in our understanding of the universe, new discoveries in particle physics, and insights into dark matter are not only a testament to human ingenuity but also a window into the fundamental nature of existence. However, like all great scientific endeavors, the LHC carries risks. It must be approached with both respect and caution. The LHC represents the cutting edge of scientific exploration, where theoretical physics meets experimental physics. Its capabilities allow it to address fundamental questions about the universe, including the nature and origins of mass. While dark matter remains one of the greatest unsolved mysteries in physics, the LHC's experiments are supported by unprecedented safety measures and large-scale simulations. Still, its immense size and energy output evoke both awe and unease. Each experiment conducted at the LHC explores uncharted scientific territory. While most scientists remain confident in the safety of these experiments, what if unexpected anomalies arise? What if our current understanding of physics is incomplete? The LHC stretches the limits of human knowledge, pushing the boundaries of what we can control in the natural world. By recreating conditions that have been hidden since the Big Bang, the LHC allows us to investigate some of the most fundamental aspects of reality. These high-energy collisions provide insights into dark energy, dark matter, and the fundamental nature of gravity. One of the LHC's most celebrated achievements came in 2012 when CERN researchers confirmed the existence of the Higgs boson, a particle responsible for giving other particles mass. This discovery solidified the LHC's role as an invaluable tool for scientific progress. However, the LHC is not solely focused on the Higgs boson. It is a gateway to a vast array of particle-related phenomena. While it has advanced our understanding in remarkable ways, debates persist about its potential risks. Some concerns include the possibility of creating tiny black holes or destabilizing the fabric of spacetime. Despite these concerns, rigorous safety protocols, simulations, and peer reviews have been implemented to prevent catastrophic outcomes. Scientists have reassured the public that the LHC operates well within Earth's natural energy levels. These safeguards ensure that the LHC can continue to push the boundaries of known physics while remaining a source of both fascination and anxiety. Operating in the realm of quantum physics, a field where logic is often at odds with intuition, the LHC holds the potential to uncover exotic new dimensions, detect unknown particles, and enhance our understanding of gravity. The world's brightest minds anticipate the next revolutionary discovery with both excitement and trepidation. If the LHC succeeds in revealing new forces or particles, it would mark a significant milestone in human comprehension. Despite the inherent dangers of such groundbreaking research, the pursuit of knowledge often requires taking risks. The human drive to explore the unknown, to unravel the mysteries of existence, and to deepen our understanding of the universe is an essential part of who we are. The LHC embodies this insatiable curiosity. Even the smallest discovery has the potential to revolutionize our perception of reality. As we continue to explore the scientific unknown, we will undoubtedly persist in our quest for knowledge, one of the most daring and ambitious human endeavors. Yet, the deeper we peer into the unknown, the more we realize how little we truly understand. Each discovery at the LHC not only answers existing questions but also raises new ones, opening doors to mysteries we never anticipated. For instance, if extra dimensions do exist, what might reside within them? Could they harbor unknown particles, new forces, or even entirely different forms of matter? And if we were ever able to interact with these dimensions directly, what implications would that have for our understanding of physics, space, and time itself? Even now, physicists speculate on the possibility of parallel universes or alternate realities. Some theories suggest that gravity, one of the weakest fundamental forces in our observable universe, could be leaking into other dimensions, explaining its relative weakness compared to electromagnetism or nuclear forces. If this theory holds true, then the LHC may be the key to unlocking proof of these hidden realms. But with every new frontier comes uncertainty. If we do discover these dimensions, could we inadvertently expose ourselves to phenomena beyond our comprehension? Just as early scientists feared that breaking the sound barrier might trigger unknown consequences, so too do some worry about the unforeseen risks of pushing the limits of high-energy physics. Nevertheless, science has always thrived on uncertainty. It is in the moments of doubt, in the gaps between what we know and what we have yet to understand, that the most groundbreaking discoveries emerge. The LHC represents not only an instrument of immense scientific power but also a testament to humanity's relentless pursuit of knowledge. Looking ahead, future upgrades to the LHC will push its capabilities even further, allowing researchers to explore higher energy collisions and more intricate subatomic interactions. These advancements could lead to the discovery of new particles, offer deeper insights into dark matter, and perhaps even redefine our understanding of spacetime itself. The quest for knowledge is unending. As long as there are mysteries to unravel, as long as there are questions left unanswered, humanity will continue to search, to explore, and to challenge the limits of what is known. Whether through the LHC or its successors, we stand on the precipice of a new era of discovery, one that may ultimately reshape our perception of reality. And so, the embers of doubt continue to glow, flickering in the shadows of our understanding, urging us ever forward into the unknown.